Welcome back to our foundational training series, designed to introduce new users to LARSA 4D. In this session, we'll introduce the LARSA 4D Section Composer, a powerful standalone tool that's included with your LARSA 4D installation. You'll find it right in your Windows Start menu, ready to go. The Section Composer provides a flexible environment for analyzing and designing bridge and building structures with non-standard or non-prismatic sections. It supports composite sections made from multiple materials and allows you to build sections using a combination of standard, parametric, and fully custom shapes. It's also capable of computing essential section properties, including for shapes you draw yourself, giving you everything you need for structural analysis. You can run Section Composer either directly from its executable file or from the Tools menu within the main LARSA 4D environment. Let's take a moment to get familiar with the user interface and some of the key terminology you'll encounter. In Section Composer, a shape refers to a polygon that defines the outline of a part of your cross-section. By default, a shape is solid. If you want to create a hole, you'll insert a cutout shape inside. Shapes can also be embedded within each other. This is how we model composite action, when different parts of the section have different material properties. There are three types of shapes you can use. Standard shapes. These are predefined shapes from LARSA 4D's built-in database. Their parameters and coordinates cannot be modified. Custom shapes. These shapes are also from LARSA 4D's built-in database, but you can modify their parameters and coordinates to fit your needs. Free shapes. These are shapes that you create from scratch. You have full control over the points, parameters, and dimensions. Sections are created by combining these shapes together. You can even add multiple sections to a single Section Composer file. We call these files section databases. Section databases can be linked to your LARSA 4D projects, making the custom section properties available for your structural models. Once linked, the sections in the database become available to assign to members in your LARSA 4D model. At first glance, you might notice that the assigned sections appear rotated 90 degrees. This discrepancy is caused by a difference in how the vertical direction is defined in the member reference axis in Section Composer and the vertical axis used in your LARSA 4D model. To resolve this, you can simply apply a 90 degrees orientation angle when assigning the section in LARSA 4D model, ensuring proper alignment. This highlights the importance of understanding how member reference axes work, so let's take a closer look. The member reference axes define the coordinate system of the Section Composer canvas. In this system, the y-axis represents the vertical direction, the z-axis represents the horizontal direction, the x-axis points into the screen and is referred to as the member reference line. This reference line is more than just a visual guide. It represents an imaginary line that connects the joints of a member in your LARSA 4D model. It plays a critical role in determining how your cross-section aligns with the rest of your structural geometry. One of the key advantages of this system is flexibility. Your joints don't need to be located at the centroid of the section. When you move your section in Section Composer, the section assigned to the member in the LARSA 4D model will automatically adopt its new position. This flexibility becomes especially valuable when your known dimensions are based on the top of the section rather than the centroid. This becomes especially useful for non-prismatic sections, where the section dimensions vary along the length of the member. In Section Composer, non-prismatic variation is defined using shape parameters, which are listed on the right side of the window under the Parameters tab. You can add, remove, or modify these parameters as needed. For example, for a rectangular section, if we want to assign a variation to the depth parameter, we click the small button next to it to open the Parametric Equation Editor. This tool lets you define custom, linear, haunch, parabolic, or sinusoidal equations. In the Custom Equations tab, for instance, you can enter a formula like 30 plus 30 times x to the power of 3, where x represents the relative span position. X equals 0 corresponds to the start of the member, and x equals 1 corresponds to the end. After entering the equation, click OK. Next, go to the section menu and choose Non-Prismatic Variation. This window provides comprehensive information on how the section and its properties change along its length. In the Section Diagram tab, the top diagram shows the cross-section for a given relative span position, which you can adjust using the slider. The bottom view shows the overall non-prismatic variation of the section from a side view. In the Properties tab, you can track how section properties vary across the span. Now close the window, open a LARSA 4D model, and assign the section to a member. You'll see the non-prismatic geometry appear, but keep in mind LARSA 4D performs analysis using constant section properties along each member element. So, to more accurately capture the variation, the member should be divided into smaller segments. To divide the member, go to the Modify menu and click Break Members. Enter 20 in the Number of Segments box and click OK. You'll notice that each segment now has its own relative span. The position is set to 0 at the start and 1 at the end of each individual member. As a result, the non-prismatic variation resets for each segment. However, what we want is a continuous non-prismatic variation that starts at the beginning of the first segment and ends at the end of the last segment. To achieve this, go to the Draw menu, select from selected members, and then click Span. This will create a span across the selected members. Now the non-prismatic variation will apply smoothly across the entire length of the divided member. Let's continue with composite sections. In Section Composer, you can define a composite section by adding multiple shapes to the canvas. These shapes can be positioned freely using the alignment tools in the toolbar. To precisely join shapes, use the Snap tool to align their edges. Each shape can be assigned a different material by clicking Composite Materials in the section menu. After assigning materials to each shape and selecting a reference material, Section Composer automatically calculates the composite section properties based on the chosen reference material. Additionally, Section Composer supports staged construction modeling for composite sections. You can specify when each shape is cast or constructed, which is useful for staged construction analysis. You can also define reinforcement using the Draw Rebars tool. Clicking it opens a window where you can specify rebar properties like type, material, and cover distance. Once you close the window, the rebars are placed on the section accordingly. This reinforcement data is utilized by LARSA 4D C-Suite's Moment Curvature tool, Biaxial Interaction tool, and the Code Check tool. That brings us to the end of this tutorial. Thank you for watching. We invite you to visit our website larsa4d.com for more training videos.